this picture, and he's got all the maths included, and it looks good. At first I had a little tough time with it because there's a couple things true about it, right? It's showing the sun traversing over the ground, over the flat earth, and it's parallel to the ground. So it had that going for it. And it's showing that when the sun is further away from you, it angles down, just like perspective. Same as this guy, Daz, the cameraman or something is his name. He has a video out and he shows this picture. And it's the same thing. It still shows a parallel sun to the ground. And instead of moving the sun, he's moving the observer. But it's the same diagram. If you flip it upside down, it looks identical. Anyway, so it's the same notion. So I was a little bit perplexed. I was like, wait a second. Makes you start to doubt. But I mean, I know it's wrong, but I was like, wait a minute, it's got perspective. It's so I thought. And then it hit me. What's wrong with this picture? What's wrong with this picture is that they are attempting to calculate visual angles to the sun from a non-visual, non-perspective drawing. So the drawing is not taking the visual perspective of the observer into account, and that's what's wrong with this diagram. You see, you cannot calculate visual angles to convergent positions, which is where the sun is from the observer, by using non-convergent parallel lines, which is what they're doing in the diagram here. They have two parallel lines and they're drawing visual angles to it. It's true that this drawing is an accurate representation of actual relationships and positions of the observer to the sun, but it's a non-perspective side view representation. So this diagram is not accurate at all as it relates to the perspective of the observer.
So people, then finally Pea Brain will come up with a video like this, in his video with a picture like this, and let's investigate his fallacy. Here, sorry, I need a pen and I need some baker. There, that is the 12 o'clock, and then he says the sun goes down there, which I think is completely bollocks, and that is where the whole fallacy, the straw man, comes from. Let's have a look at this picture. It's from a wall, and if we count 1, 2, 3, oh, there's 1, 2, 3, 4, 5. There's approximately 50 centimeters of wall height, because if you go there all this way up, you will find more than 25 of these bars mounted against the wall. And if they're including the space between are approximately 10 centimeters, then you will have a ceiling height of 2.5 meters, which is quite okay. And that means that here we have 50 centimeters as what represents the height of the sun. Now we see here, and we see there, and we see there, and they get closer and closer, bars that are also probably 50 centimeters apart to mount these rails on. So that means if the 50 centimeters here is the sun at 4,000 kilometers height, then the sun here is 4,000 kilometers away. And by the time it sets, it is there, 8,000 kilometers away. It doesn't get there, you know. That is wrong. The best you get is a sun about 8,000 kilometers away when it sets. And now watch where his problem is. It doesn't get down. It doesn't get down. The whole trick in his fallacy is that this distance in this direction is shorter and gets shorter every step, and he acts as if it is the same, and that is a fallacy which I prove in my video. Thank you.
Hey folks, here I am again. I want to play a bit around with the setup I used before to show how high the sun would be over a flat earth. And what I did now is first to give an impression where the ice wall would be. That is the yellow hose, and I will take it away later, but so that you have at least an impression. What we're going to do now is see if perspective can make our sun. Hold on. So notice this is already wrong. If you see this, it means you basically have your eye in the sand. And many flat earthers make videos like this, and they have their head in the sand. So your eyes are of course always above. So, but for the flattards, I'm going to help them a little bit with this. Now what I'm going to do is I'm going to bring the sun a bit further away and see if it is able to touch the horizon. Now the sun is an entire flat earth diameter further away. And we can still see it, can't we? And otherwise we have to zoom in a little bit to see that it is still high up there. It doesn't go down to the horizon. But remember, the distance is already an entire flat earth further. I'm going to take it another one further. And as we see, it is still there. I'll take the ice wall away. Yep, that's how easy you dispose of an ice wall. Now we're going to zoom back to normal view to have an idea how small it would be, and still not touching the horizon. But we are already so far away that, as you can see, the sun would have to be completely way out of its normal path to even get to something that looks like a sunset. Let's go to the next one. So we cleaned up stuff. You will be wondering what the hell is he showing now. Well, this is again the sun basically in the east, looking from that point. Yeah, it is where. Okay, let me place it a little bit here. There. Now it is basically in the east, looking from that point there, and that point is what you could see as a plane, a huge plane. It's more than 10 kilometers long, and it's flying over the clouds. You see? It is just flying over the clouds. Please focus. Come on. Focus, 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 focus. Problems with autofocus. And now the question is, if that is a plane that is flying over the clouds, how can it see that sun there below it, as you will see in the pictures? How is it possible? We've just seen that if I take a distance of 3 times the flat Earth, the sun is not down enough from a perspective point of view, but how could it even be below the clouds for a plane flying over 20 kilometers high and clouds? And there's the wind, and as usually the wind blows clouds away. Thank you.